Okay, this section, it's section 13.3 of the text, controlling hormonal secretions. This seems a little out of place to me, but it's still good information. They talk a little bit here about half-life. And considering that most of you taking this course are probably going into nursing, this is something that's going to be familiar to you if it isn't already. Half-life is the time it takes for half of the hormone molecule to be removed from the plasma. Of course, you could also talk about the half-life of a drug in the body. If you take 100 milligrams of a drug, the time it takes for that 100 milligrams to be dropped down to 50 milligrams by whatever means. Maybe you're getting rid of it, maybe you're breaking it down, but the time it takes for the original concentration to be cut in half is called the half-life. So they use as an example here, if you had a hormone with a half-life of 10 minutes, it starts out at 100% of its blood concentration. And if you stop secreting it so that that's all there is in the blood, then it'll drop down to 50% in 10 minutes. And that 50% will be cut in half to 25% after 10 more minutes. And the 25% will be cut down to 12.5% in another 10 minutes, and so on and so on. So hormones with short half-lives of just a few minutes control body functions that turn on and off relatively quickly. But hormones with longer half-lives, like thyroid hormone and some of the steroids, they may have half-lives in the days instead of minutes. All right, so control sources. Control of hormonal secretions is essential to maintaining homeostasis. Hormone secretion is generally controlled three ways, but all three of those employ negative feedback. There is a section back in chapter 1 about negative feedback. A good example that I think most people can relate to of negative feedback is a heater or an air conditioner. Or maybe you have both of those combined into a heat pump unit. But let's just talk about heat for a moment. You go to the thermostat on the wall and you say, I want it to be at least 70 degrees in here. You set it to 70. If the temperature is lower than 70, the thermostat will respond to that by turning the heat on. It will blow hot air into the house until the temperature rises up to 70. And at that point, when you've achieved that set point, it will shut off. It could go the other way. In the summer, you might say, I want the air conditioner to keep it either 72 degrees or cooler in the house. Early in the morning, it might be cool enough that it's only 70 degrees in the house without the air conditioner running. But as the day warms up, the temperature rises. When it goes above 72, the thermostat will turn the air conditioner on. It will blow cold air through the ducts until the temperature drops down to 72, and then it will turn off. So that's negative feedback. As temperature goes up, you blow cold air to bring it back down, the opposite of what's happening. Okay, so let's look at these three different ways that hormone secretions are controlled. One, the hypothalamus, which again is this is probably not a good way to say it, but the floor of the brain, constantly receives information about the internal environment, and it controls the anterior pituitary gland. Now, I should have said this earlier, but a lot of times we hear the pituitary gland mentioned, and the pituitary gland really is two separate glands. You could even make a case for a third section, but the anterior pituitary works in a completely different way from the posterior, and we'll be seeing that in I believe the next video. We'll be talking about the anterior pituitary gland, its structure, and how it works. Well, the pituitary gland overall. So the anterior pituitary gland is controlled by hormones from the hypothalamus. Now, let's see here. Many anterior pituitary hormones will affect activity of other glands, so that's why the pituitary is sometimes called the master gland. The hormones that act on the other glands are called tropic hormones. Remember, tropic means influencing. And as an example here, when blood levels of cortisol get low, corticotropic releasing hormone, CRH, gets released from the hypothalamus. It travels a very short distance down into the anterior pituitary gland where it stimulates secretion of adrenocorticotropic hormone, or ACTH. And that is actually made by the anterior pituitary gland. Then that leaves the pituitary gland through the bloodstream and stimulates secretion of cortisol by the adrenal cortex. And that, of course, makes the cortisol level rise, which shuts off this negative feedback loop. So that's one way. Hypothalamus controls the anterior pituitary gland, which in turn controls other glands. Second way is the nervous system can directly stimulate some glands. The adrenal medulla secretes hormones epinephrine and norepinephrine, which are also known as adrenaline and noradrenaline. So this is in response to impulses from preganglionic sympathetic neurons. Remember, the sympathetic nervous system associated with fight or flight. So you see a situation that is startling, that is maybe life-threatening. The sympathetic branch of the autonomic nervous system will stimulate your adrenal gland to secrete adrenaline, or as it's also known, epinephrine. And epinephrine has effects such as speeding up your heart rate, your breathing rate, dilating your pupils, making your mouth go dry and your palms get sweaty, all those things we associate with fight or flight. So that's a case of the nervous system directly stimulating a gland. The third possibility, you have some glands that respond directly to changes in composition of the internal environment. And the example they give here is if your blood sugar, your blood glucose level goes up, your pancreas will secrete insulin. And if your blood glucose level gets too low, it will secrete glucagon. So we will talk about insulin and glucagon and the cells of the pancreas that make those. But the point here is that insulin secretion is controlled by the blood sugar level directly. The pancreas will secrete it if the blood sugar level gets too high. It doesn't need the nervous system to tell it to make insulin. The pancreas does not need the hypothalamus to send it a signal to make insulin. It monitors blood sugar levels itself. And we've got three little flow charts here about those three mechanisms, with the hypothalamus sending signal to the anterior pituitary gland, which sends signals to peripheral endocrine glands. That leads to that action, but also the hormones from those will come back up here and can shut either of these off. The red dot there shows you the negative feedback reception. With I lost what I was going to say here. With the adrenal gland secreting adrenaline, for example, the nervous system stimulates the adrenal gland, and that adrenaline comes back to the nervous system and shuts off the negative feedback loop. And then if you have a substance in the blood plasma, if its level changes like sugar, then the endocrine gland, in that case the pancreas, sends insulin to the target cells, which are primarily the muscles. The muscles take sugar out of the blood, and the lowered blood sugar level shuts off the negative feedback loop. So that's the main thing I wanted to point out to you here in this section. Going forward, the rest of the chapter, we'll be looking at the different glands, their anatomical structure. We'll talk about the hormones they produce and what those hormones cause.